Dear students, in this video we will be discussing about binary file operations. If you remember, we have discussed about text file operations, we have discussed about how to read from a file, how to write into file, and then what does it mean of file stream operations, how we can differentiate output stream to input file stream, and what does it mean if we associate object of output file stream, what does it mean if we associate with an object of input file stream. So how you can read and write to a file. So now moving in the same direction a little bit further, we will discuss about binary file operations. What are binary files and how we can perform operations on binary files. So for every file there are two pointers associated. Each file associate two pointers. One pointer is called input pointer, or we can say it get pointer, and another pointer is called output pointer or put pointer. The input pointer we use for reading the contents of a given file location, and output pointer put pointer is just to write. So the basic thing is every file has two pointers, input pointer and output pointer. Input pointer is for reading and output pointer is for writing. Input pointer is also known as get pointer and output pointer is known as put pointer. So there are some default actions on a file. When to open a file in read-only mode, the input pointer is automatically set at the beginning so that we can read the file from the start. Whenever you open a file from read-only mode, so by default, the default setting of input pointer is at the beginning of the file. So it means when you want to read the file, automatically it will start reading from the beginning. Okay, it does not mean that you cannot start reading in between. For that you have to think ways and means, that also we are going to discuss. But the default location of input pointer is the beginning of file. Similarly, when we open a file, in write-only mode, the existing contents are deleted and output pointer is set at the beginning. This enables us to write to the file from the start. So whenever we open a file for write-only mode, so it means whenever you open a file for writing, so if the file exists, all the existing contents of that particular file is deleted and the output pointer is set to the beginning. If file does not exist, so it means it will create a new file and then it will open it for writing purpose. So if we want to open an existing file to add more data, for example, you don't want to delete the content, you want to add some more data, then you have to open the file in append mode, not only write only mode. You have to open the file in append mode. So this is the particular description of input pointer and output pointer. So when you open a read-only file, let's say your file has two words, hello world. So when we open this file in for reading only, input pointer will set at the beginning. This is our input pointer. For the same file, if this file is open in an append mode means when you want to add more data. So output pointer's location will be, these are the default location for input and output pointers. So output pointer's default location will be at the end of the file. But if you do not open in append mode, you open only in write mode, then output pointer's default location will be at the beginning. So now there are some functions through which you can manipulate the pointer. What does we mean by manipulating? We know that default locations of the pointer. In case of input pointer, it will be in case of input pointer it will be beginning, in case of output pointer it will be if you are opening in append mode it will be end. So how you can manipulate these pointer position? For example, you want to read somewhere from in between from the file. So how you can manipulate? So there are some functions with these file pointers that are used to manipulate the pointers. First one is seek G. Basically we have two functions, seek and tell function. If we are talking about input pointer, then function will be seek G and tell G. If we are talking about output function, then function will be seek P and tell P. So seek G moves get pointer or input pointer to a specified location. How you are going to specify location, that we are going to discuss in the next page. Seek P moves the put pointer or output pointer to a specified location. So seek pointers are for moving the seek functions are for moving the pointers, and tell function will tell you the location where your pointer currently is. So tell G gives the current position of the get pointer, and tell P gives you the current position of the put pointer, where currently put pointer is. So for example, this infile for example, infile is an object of for example, infile is an object of ifstream class. So if you write infile.seekg 10, so it means this statement moves the file pointer to the byte number 10. So for example, you took a binary file and your data in the file is stored in the form of bits. So this statement will move file pointer to the byte number 10. So the bytes of the files are numbered from 0. So it means this pointer will move your pointer to the 11th byte. This function will move the pointer to the 11th byte. So infile.seekg10 means this seekg pointer will move your input. This seekg function will move your input pointer to byte number 10. So let's say we have this statement of a stream file out. So it means file out is the object of stream class. Here file out is the object of stream class. And when you say file out dot open hello. So let's say hello is the file name, comma ios append. ios append means you are opening the file in append mode. So append mode means when your file opens in append mode, it means your output pointer will be at the end of the file. So it means we have one function, that is tell function. Tell function gives us the location of your pointer. So it means if we say file out object name dot tell p, it will gives us the last byte, number of last byte. So because we open the file in append mode, it means correctly your output pointer will be at the end of the file. So it means by this way you can know that how many bytes are there in your file. So this P will store number of bytes. On the execution of this statement, the pointer is moved to the end of the file hello, and the value P will represent the number of bytes in the file. So this seek function can take either one argument like this. It will move pointer to the byte number 10, or it can take two arguments also. One argument is offset and another argument is reference position. Both seekg and seekp, offset and reference position. Now what does it mean by offset and what does it mean by reference position? So offset means how many bytes you want to move, and reference position means from which position. It doesn't say that you want to move every time it will move from the beginning. You can give your position also. So offset represents number of bytes in the file pointer is to be moved from the location specified by the parameter reference position. Reference position takes one of the following three constant. Position can be any of the three. IOS beginning, so start of the file. IOS current means current position of the pointer, or IOS end of the file. So when we talk about end of the file, it means pointer can come backward. It cannot go forward because already it is at the end of the file. So here are some example of this. For example, faut is an object of stream. faut.seekg 0, ios beginning. It means now your seekg will be 0th byte from the beginning. So it means it will go to the start of your file. Similarly, faut.seekg 0, ios current. Wherever you are at the current position, it will go 0 byte from the current position. So it means it will stay at the current position. faut.seekg 0, ios end. It will go 0 byte from the end. It means it will go end of the file. Similarly, faut.seekg m, ios beginning. It will go move to m plus 1 byte in the file because byte number starts from 0. So it will move from m plus 1th byte from the beginning. Seek m, go forward by m bytes from the current position. Now seek minus m, because iOS current, it will go backward. It can go backward also, it can go forward also. fout.seekg minus m, comma IUL. It will go backward by m bytes from the end. So from beginning you cannot use, if you are using reference position beginning, you cannot use negative parameter. From current position or end position you can use backward parameter. But if your current position is at the beginning and you are going to use a negative parameter, you will get an error. So then we have two functions. The put function write a single character to the associated string. Similarly, get function read a single character from the associated string. So now we have two functions, read and write function, unlike the put and get function, because put and get function only read and write one character, but seek and read and write functions handle the data in the binary form. So whenever we are talking about writing binary files, so we will use read and write functions. Values are stored in the disk. Why we are using binary files? What is the use of these binary files? So these files are little bit faster. How? Values are stored in the disk file in the same format in which they are stored in the internal memory. It means in the 0, 1. An int take 4 bytes to store its value in the binary form irrespective of size. But a 4-digit int will take 4 bytes to store in the character form, because character 4-digit int. So now every digit of your integer will be stored character by character. So if your int will be 8 digit, it will take 8 bytes. The binary format is more accurate for storing the numbers as they are stored in exact internal representation. There are no conversion while saving the data. Therefore, saving is much faster, because already whatever you stored in your file, that is stored in the binary format. So whenever you save it to file, you are reading it from your program with the help of your program. You need not to do any type of conversion. So it is a little bit faster. So these what is the format of read and write functions? So read and write function, let's say file is the object of file stream, f stream, or it can be of stream or if stream also. So read function char asterisk ampersand v, comma size of v. So what is this char asterisk ampersand v and size of v? V is the variable which you want to store. So in both functions, v is the variable which you want to save or you want to read. So here it is the address of v. The first is the address of variable v, and the second is the size of that variable in byte. The address of variable must be kite to type character, because it pointer to character type, because I already told you that it is stored, it saves everything character by character, and then it gives you, it is stored size, that what is the size of that variable. So for that particular means how many bytes are reserved for one value. The output objects of other types, we must convert the pointer to those objects to type const character. So whatever is the type, first we convert them into character pointer and then we store their size. So these are called random access files. Sequential access, what we have seen till now are text files, our sequential access. We were reading data one by one. But random access means you can from beginning you can go to the end, then you can come back to any position. So random access files are the files in which records can be accessed in any order, also called direct access file. These are more efficient. Obviously, whenever we will use them for real world application. It is not so that if we have 100 data inputs saved, then every time we want to read all 100. Maybe we read only 2. One is 50th, another one is 75th. So random access files are more efficient. Real-time application required immediate response. Example, respond to customer query about a bill sequencing through records for account is time sensitive. Or random immediate access meets real-time needs. They give customer needs. Okay, so how to write these random access files, and how now we will see how to write these random access files, and then we will see a program also about these random. Okay, in this video we will check about how to read and write from binary files and how to use read and write functions. So let's say for example we have a class name is person, and this class person has two private members, and let's say members are as usual name, and another one is of type integer age. Then let's say this class has two public functions. Let's say void set data. This take two arguments, name and age, and like this, name is equal to name, this age is equal to age. And then this class has another function, that is get data, just to print that data. Okay, so cout, let's check it, cout name is equal to name, go to the next line, and then age is equal to age, and then go to the next line. So this is a simple class, nothing to explain about this class. Now let's say we want to write a binary file, so using read and write function. So let's say, for example, I write an object for this class person, and let's say my object is P. So because now we will give the data, set data for this object, and whatever is the name and age of this object we want to save to the file. So first we have to declare object for class person. Now let's say I declare an office stream object, because we know office stream is just to write the file out. Let's write some file name. So let's say my file name is out file, and let's say I want to open this out file in binary mode. So it means my file is going to be a binary file. And then let's say, just because we want to call set data, so let's say we have two other variables, name and age, and just input these variables. So cout input name and age. So when we write cout input name and age, let's go to the end line. So let's see in name, see in age, and let's, whatever we have write on our I stream, we want to write that particular thing to our file, and file is a binary file, and file name is out file. So we will call, so first we will write this p dot set data. First this should be the stream set data, name comma age. Now the value for this object person we want to save to the file. So our function is, for writing our function is write function. So write, so our object name is out dot write, and we have to convert everything to character, character pointer. So let's write it inside bracket, char asterisk, and what we want to give, address of variable, and which is our variable? Our variable is P, address of P, and then we want to give size of person or P, both are same. If you write person, then also it will give you size of object of class person. If you write P, then also it will give you size of P. And after writing, what we should do, we should close it. So out dot close. So here what I did, I opened the file using constructor. I could open this file using open function also, or let's open it using open function because I like that. Open, and let's write this here. And simply declare variable here. So this what we did, we declare an object of office stream, that is out, and then we open a binary file, out file, and then we simply save object class person, name and age using set data to this file. Let's see what happened. Let's see what happened. So when we run this, it will asking us name and age. So let's say name is XYZ, age is 12. It will not show anything here because we have saved this to that file, and we are not getting it from the file. We didn't use any if stream object. So now let's check the location. This is my project 10, or see here I have saved the project inside Visual Studio. Project is project 10. So inside project 10, here is file, out file. Now because it's a binary file, so we have to search. Let's say we want to open it on Notepad. Let it be open. Okay. See, whatever we written, we cannot see that. However, something matches, but it's a binary file. So everything is in binary format. So character by character, every single character converted into a byte, and then that is saved. So its reading is a little bit faster because same thing, it need not to convert anything. Whatever object code is there, it is saving that object code. So when you will read, it will give you a correct means input, correct values, whatever you have saved. So for example, let's say I open an object of ifstream. Let's say object is in, and in dot open, and let's file name should be same. File name is out file, and because input pointer by default will always be at the beginning, and because here we open it in because here we want to tell the compiler that this out file, if there is no file with name out file, it should be a binary file. So we write the mode, binary mode, but because this is for reading, so it means file has already been created. We need not to specify it here. Now let's say same thing, in dot read, and inside read also the parameter of read char strict ampersand p comma size of p, and then how we will get it on our screen? Through get data, p dot get data, and then we should in dot close. Now let's check it. Let's run it. So ABC and 12. So it will give you ABC and 12. But earlier what we saved? We saved XYZ. But our file is in truncate mode. If we do not specify, default mode is truncate mode. Truncate mode means every time it will delete the data and it will open it in as a new file. So if you do not want to do, if you want to save everything, so just open it in append mode, and we have already discussed about this append mode. So it will add everything at the end. So now let's also check it again. So let's say again I write XYZ and age is 25, but still it will read the first record ABC and 12, because what I told you, that input pointer and output pointer, default location of input pointer is always at the beginning, and we are reading only one record, so it will read only one record from your file. So starting from beginning. So doesn't matter that how many records are there. Whenever you will read it like this, it will read only one record. If you want to read all the records, or if you want to go read like this, then what you have to do, that also we will be discussing in a separate video, that how to use using seek and tell pointers we can read everything. So how to do that, that also we will discuss. So this will read only first record, no matter how many records we enter. For example, we add another record PQR 25 or another record HKL 56. So no matter how many records we enter, it will obviously always read the first record. Okay. So now let's say you want to read the complete file. So that is quite simple. You will put this read function inside the while. So it will read your complete file. This we have discussed in case of text file also. So if you do it like this, it will read until it goes at the end, until read functions get its input. So let's put another, let's say KLM. So it will give you all the records, whatever records we have put. But the thing is that, for example, I do not want to read this ABC, XYZ or KLM. I want to read only PQR and HKL, name and 23 and 56. If you want to read only these records, then also yes, we can work, and those type of files are called random access files that we will be discussing on next video. So to use this, to access these random access files, we always use seek and tell pointer. Here is the use of seek and tell pointer, what we have discussed. So in the next video, I will write a program about random access files, that how to move from random access files, and then we will say how we can delete the data, how we can change your file name of the program. So all these things we will see. So in the next video, I'll tell you about that. Thank you.